A Snickers bar looks simple, but inside a factory it moves like a tiny building project. Every bar is a stack of nougat, peanuts, caramel, and milk chocolate. A single bar weighs about 1.86 ounces or 52.7 grams. To make millions of them, the factory turns sugar, milk, nuts, and chocolate into a moving river of candy. It starts with the raw materials. Tanker trucks bring in liquid sweeteners like corn syrup, dry sugar, and it arrives in bulk bags or silo trucks. Milk powders arrive sealed against moisture, and roasted peanuts come in large food-grade containers. Chocolate ingredients arrive as cocoa butter, chocolate liquor, milk solids, sugar, and emulsifier, or as finished milk chocolate, ready to be melted and tempered. The official Snickers ingredient list includes milk chocolate, peanuts, corn syrup, sugar, palm oil, skim milk, lactose, salt, egg whites, soy lectin, and flavoring. So every one of those ingredients has to be tracked before it ever reaches the line. At the receiving bay, workers and automated systems check lot numbers, supplier records, allergen labels, and temperature logs. Peanuts are one of the most watched ingredients because they affect flavor, texture, weight, and food safety. Before they are used, they pass through screens that remove dust, broken shells, and pieces that are too small. Magnets catch stray metal. Optical sorters use cameras and bursts of air to kick out dark, damaged, or foreign pieces. The goal is simple. Only clean, evenly roasted peanuts should reach the candy line, because one bad piece can ruin the texture of a whole bar. The dry ingredients move through enclosed pipes and screw conveyors to keep the room clean and reduce dust. Sugar and milk powders are weighed by load cells, which are scales built into the hoppers. Liquid corn syrup is pumped through stainless steel lines from heated tanks so it flows smoothly. Each batch is measured by computer-controlled valves. In a factory this large, guessing is not allowed. If the nougat has too much syrup, it becomes sticky. If it has too little, it turns dry and breaks when cut. The first major layer is the nougat. In simple terms, nougat is whipped candy. In the factory, sugar syrup and corn syrup are cooked in steam-jacketed kettles or continuous vacuum cookers. The syrup is heated until enough water boils away to leave the right sugar concentration. For soft candy textures, caramel-type syrups often sit around 118 to 121 degrees Celsius, while firmer nougat-style syrups can move into the hardball range, around 121 to 130 degrees Celsius. Higher temperatures remove more water, which gives the candy more structure. While the syrup cooks, egg whites or egg white powder are prepared in a separate mixing system. The egg white helps trap air. When the hot syrup is ready, it is fed into a high-speed aerator or planetary mixer. The blades whip air into the syrup and egg white mixture, turning a dense liquid into a lighter, chewy foam. Peanut flavor and fat are blended in to give the nougat its familiar taste and mouthfeel. The machine has to work fast because the candy thickens as it cools. Operators watch temperature, density, air content, and mixing time. A small shift can change the bite from soft and stretchy to tough and grainy. From the mixer, the warm nougat drops into a forming hopper. A wide depositor spreads it onto a moving belt as a continuous slab. Side guides keep the slab at a fixed width, and leveling rollers press it to the correct thickness. The belt is usually coated or made from a release material, so the sticky nougat does not cling to it. At this point, the candy looks nothing like a bar. It's more like a long mattress of soft nougat moving down the line. The slab then enters a cooling section. Cold air and chilled belt plates pull heat out of the nougat just enough to make it stable. Cooling cannot be sudden. If the outside firms while the inside stays warm, the slab can wrinkle, split, or trap heat that later affects the caramel. Sensors measure surface temperature as the slab exits. Workers check samples for height and chew. The nougat has to be strong enough to carry caramel and peanuts, but still soft enough to bite through. Next comes the caramel. Caramel starts with sugar, corn syrup, milk ingredients, fat, and salt. The mixture is pumped into a cooker where steam heats the jacket around the vessel, while scrapers keep the candy from burning on the metal wall. In some plants, a continuous caramel cooker does the job without stopping. The ingredients pass through heated tubes, loose water, and thicken as they move. For a chewy caramel layer, the candy is commonly cooked near the firm ball range, around 118 to 121 degrees Celsius. That range matters because it leaves the caramel firm enough to hold shape, but soft enough to stretch when bitten. The caramel is checked for moisture, color, and viscosity. Viscosity is how thick it flows. Too thin and it runs off the nougat. Too thick and it will not spread evenly around the peanuts. Color meters can check whether the caramel is too pale or too dark. A pale caramel tastes flat. A scorched caramel tastes bitter. The factory wants the same golden color every time. The peanuts are added at this stage. Some lines spread roasted peanuts over the nougat first, then coat them with caramel. Others mix peanuts into the caramel flow before it lands either way. A vibrating feeder meters the peanuts at a controlled rate. The feeder shakes gently so the peanuts fall in an even curtain and not in pile. The goal is to make sure every bite has peanuts, caramel, and nougat, instead of one section with too many nuts and another with none. As the caramel and peanut layer is laid down, a heated spreader or roller smooths it across the nougat. The caramel must still be warm enough to flow around the peanuts, locking them in place. But it cannot be so hot that it melts or collapses the nougat underneath. This is one of the trickiest moments in the process. Two different candy textures made at different temperatures have to bond without ruining each other. Now the factory has a full candy slab. It travels into a longer cooling tunnel. Industrial confectionery cooling tunnels can be many meters long, with controlled air zones and chilled belt sections. Some commercial chocolate and candy cooling tunnels range from 20 to 300 feet in length, depending on line speed and product size. The slab has to cool slowly and evenly until it is firm enough for cutting. If the caramel is still too warm, the knife will drag it. If it's too cold, the slab can crack. At the end of the cooling tunnel, the slab reaches the cutting station. First, rotating slitters cut it lengthwise into long ropes. Then a guillotine cutter or rotary knife cuts those ropes crosswise into individual bars. The machine times each cut to the belt speed, so the pieces stay the same length. Checkweighers sit nearby. Each bar passes over a scale at high speed. Bars that are too light or too heavy are pushed off the line by air jets or small reject arms. Weight control matters because customers expect the bar to match the package, and regulators require the label to be accurate. The cut bars now have exposed nougat, caramel, and peanuts. Before they get their chocolate shell, crumbs and loose peanut pieces are removed. The bars pass over a vibrating conveyor or under gentle air blowers. Any loose fragments fall through gaps or get vacuumed away. This keeps the chocolate coating smooth and prevents bits from sticking in the enrober. The chocolate side of the factory is running at the same time. Milk chocolate is melted in heated tanks and then tempered. Tempering is controlled heating and cooling that lines up the cocoa butter crystals. Without tempering, the coating can look dull, feel soft, or develop stale streaks called blue. A tempering machine cools and warms the chocolate through precise zones until it reaches the correct working condition. The bars ride into the enrober on a wire mesh belt. The bottom of each bar is coated first by a thin layer of chocolate on the belt or by a bottoming system. Then the bars pass under a falling curtain of milk chocolate. The curtain covers the top and sides in one smooth motion. Vibrators shake off extra chocolate from below, while air blowers remove excess from the top. This is how the factory controls coating thickness. After enrobing, the bars enter another cooling tunnel. Chocolate cannot be blasted with freezing air. It needs controlled cooling so the cocoa butter crystals set properly. Many chocolate cooling systems use separate zones, with cooler air in the middle and a warmer exit zone to reduce condensation and cracking. Cooling times for chocolate products can be around 8 to 12 minutes, depending on the product and line setup. As the bars exit, cameras inspect them. Vision systems look for missing chocolate, broken corners, odd shapes, streaks, exposed peanuts, and wrong size. Metal detectors check for tiny fragments of metal that could have come from equipment wear. Checkweighers verify the final packaged weight, target. Rejected bars are automatically diverted before they reach wrapping. Workers also pull samples by schedule. That is why a Snickers bar tastes the same, whether it comes from a corner store, a gas station, or a box in a warehouse. It's not just candy, It is a timed assembly line, built layer by layer, checked gram by gram, and wrapped before the chocolate ever has a chance to lose its shine.